So here's our first example of a rational inequality. We see that it has already got 0 on the right-hand side. So now we just need to find the real zeros of the numerator and the denominator. And I can see for this question, I'm going to need to factor. Why don't you pause your video and factor these? So we've factored the numerator and the denominator, and I want to say something about these headings I've written here. Step 1, real zeros of the numerator. Step 2, real zeros of the denominator. I know some of you don't bother writing that down, and that's a mistake. Every time I write down what I'm going to do, it helps me remember what I am supposed to do. You are learning these steps. You are trying to get them into your long-term memory so that, like it says on the class Moodle page, you will practice until you cannot get it wrong. Part of that is writing down the information you need. Now, in this question, we see that we want our rational expression to be less than 0. This tells me that the numerator cannot equal 0. If the numerator equals 0, then my expression will equal 0. So when I go to find my real zeros, I know that x minus 4 cannot equal 0 and x plus 1 cannot equal 0. So we have two critical numbers for the numerator, and both of them are going to have an open circle because they cannot be included. Now, the real zero of my denominator is going to be the same as one of my real zeros for the numerator. That's okay. We see here, because it's in the denominator, that it cannot equal 0. Remember, your denominator can never equal 0. So we have two critical numbers that we want to put on our number line. X cannot equal -1, so we're going to use an open circle. X cannot equal 4. We're going to use an open circle there as well. We've created 3 intervals. In fact, we could label these intervals. The first one is from -∞ to -1. Both have open circles. The second interval is from -1 to 4. Open circles, therefore open brackets. And the last one from 4 to infinity. We said down the right, we wanted to put our numerator, x squared minus 3x minus 4. Our denominator, and instead of writing the whole thing out again, I'm just going to say this is my rational expression, the r of x. Now remember the 5th step. In the 5th step, we had to choose a value for x in each interval. So in this interval, in the first interval, I'm going to let x equal -2. Now we substitute that into our numerator. So -2 squared minus 3 times -2, this equals 6. But it doesn't matter what it equals. All that we care about is that it's positive or negative if it ends up being negative. Substitute -2 into the denominator. 4 -8 times -2 plus 16. Again, I don't care what this equals, but I can see it's going to be positive. When I have a positive value divided by a positive value, that tells me the whole expression will be positive. In the second interval, I'm going to let x equal 0. I always choose 0 if I can. It's an easy number to work with. And then we substitute that into the numerator. 0 squared minus 3 times 0 minus 4. I see that that's going to be negative. 0 squared minus 8 times 0 plus 16. I see this is going to be positive. That tells me I have a negative interval divided by a positive interval, expression, not interval, the whole expression is going to be negative. A negative divided by a positive is negative. What number should we choose for x in the last interval? Well, any number, 5, 6, 7, 10, doesn't matter. I'm going to choose x equals 5. Can we use x equals 4? No, we can't. First of all, we have an open circle on 4. That tells me x cannot equal 4. I want to choose a number in the interval. Don't use the endpoints, whether or not they are included. So now we've got 5 squared, negative 3 times 5, minus 4. What does this equal? 6. It's positive. Substituting 5 into the denominator, I have 25, negative 8 times 5, minus 40, plus 16. I think this is also positive. Let's figure that out. 25 and 16 is 41 minus 40. It is positive. A positive divided by a positive is going to give me a positive rational expression. Now look back at our question. We want our rational expression to be less than 0. Less than 0 means we're looking for the interval where the rational expression is negative. That means I have one solution here. My solution is that second interval, -1 to 4, open brackets. Let's try another question in the next video.